The final basic concept in the Python programming is classes, and this is also a really important concept because most of the frameworks are implemented using the classes, and so it's pretty easy to construct in a project which has a skeleton and which has some object oriented reference model. So it tends to follow the programming paradigm of object oriented, so that it's pretty much readable, and it could be maintained pretty well. So that's why the frameworks are designed and implemented in Python using the object oriented concept as much as possible. So which the concepts we have already covered most of them, just like the data structure, list, dictionaries, or any kind of other data structures. When we define it in variables, they actually are nothing but an instance, or they are nothing but an object of a class. So that's why classes are really important, because most of the everywhere in Python, either directly or indirectly, it is used in the concept of objects. Okay, so let's just start with the basic syntax, how to define a class. It's with the class keyword, and you have a class name, and with the colon, just like defining a function, where instead of diff we define with the class. And inside there we'll be having all the methods and attributes, so like the instances of not exactly inside instances, the methodology which we define for the class will be inside the class construct. So sample this is one sample class. So first let me clear all the outputs. So this is one sample class. This doesn't have, it just has a doc string, and it doesn't do anything, it just skips the execution. I mean, it does nothing over there. So let's create, so when the way of creating an instance is pretty simple. You just give the class name with the parenthesis, it becomes an instance of that particular class. So we can see the type. So basically this class will be an instance type, and the type of the first class would be an class object, and this is a class object, and whatever you create a instance with it will be called as an instance. So you can create a multiple instances for a single class, and that's the beauty about object oriented object definition. So you create a multiple objects out of a single skeleton of class, and that's why we so that's one of the concepts that we basically can reuse the entire object orient entire class model for multiple scenarios. And in the advanced we'll come about the inheritance and abstraction also. So yeah, so whatever implementation we make, it will be abstract to the user who will be using the class. That's one of the methodology, or one of the features of object oriented. So we have created two objects, and we are defining we will be defining its one attribute, declaring with 5, and one more object has an attribute value 6, and this is a global attribute value 7. So you can just see the output. Vaccine 1 it has a value this, and the global has a different value. So all those will be in a different memory, so stored incomplete. They don't share any of the memory, although all these three have same value named after X. So let's consider this sample class program. So it has a counter, and these two are two methods which are the member methods of this class. And so anytime you create an instance variable, you have to specify it with the self dot. So that means it's an object. This will be an instance, or you can call it as object, and with that particular instance you are defining any class variable and assigning it a value, and this becomes an instant variable or class attribute with the particular instance. So and this will have different value for each instances. So let's consider that example. So what we are doing is we are creating an instance, and we are calling the reset operation. So this will basically reset, and this counter dot get count. So this is going to call once, and the next time you're going to call again, it will get incremented, because the same instance will be always stored instance value, and third time you get call, it will get again incremented. So when we run it, we'll get the output as this. So let's try running the same thing, but now we'll create one more counter here. So let's say counter 1, and let's just define it once. I don't want to see it, like we don't want to see multiple times. So although this counter has given the value, so right now the value would be 3 here. So once we define one more, so you can basically define it above here, the instance. So this should ideally give us again back 1, because that's a different instance altogether. Got an error. There's no attribute count. Okay, that's because I need to call this reset for counter 1 as well. So that's gonna define this initial value, so we have to set it. Okay, yeah, so we got the expected output, that's 1 2 3, and although we reset the counter long before this get count in when before the increment of this increment did not affect the increment for this instance, because this is altogether a different instance, and this still has a value 1. So let's take one more example. This is a first class, and it has name and symbol as 2 attributes, and this is init. So init is nothing but whenever there is a class instantiated, this init function is just like a constructor which will be called along with the whatever parameter you will be passing as argument to that particular init function. So these function did not have init, so basically they inherited the init of object, so that doesn't do anything. So when we have this kind of init, we pass anything like 1 and that gets assigned here. The value gets assigned to the name, and this gets assigned to the symbol, that becomes instance. When you now we print, that will be instantiated. That we can get back the value of 1 and 2. These are this formed tuple basically. Yeah, so this is how you instantiate through the constructor call. Yeah, so the one more thing to observe here is so there is one called as method called as dir. So it's pretty important, because we can so what it does is basically, let's execute this, it gives us the whatever methods it has, that particular instance has, or the class has. So if you want to check out, git count and reset are the 2 methods of this, and again these are the instances. It has same get count and reset. Along with that, it gives you the object also, object attribute as well, if it's a instance, and it has other defined like predefined method or attributes or methods. So the dir basically what it gives, a structure of the class, just like it describes that particular class. Yes. So let's consider this one more example. We will wind up with the basics of classes with this. Yeah, so we are doing nothing but here there's one more class variable. So although these are instance variable, this is called as a class variable. So this when you instantiate this, will instantiate both of them, and also this is going to instantiate to the, so there's no much difference with the instance variable and class variable. The only thing is that we don't define with the self that's instance, although this will be having one more. For each instance it allocates a different memory. And then we come to the inheritance. Inheritance is one of the a very important concept of object-oriented programming language, programming paradigm, because this makes our structure of code really readable, in the sense there will be not a lot of reusable, not a lot of repetition of code, so there will be a lot of reusable code that will be maintained pretty well, and it would be pretty readable if uh, the proper paradigm is followed while designing the classes. So let's say we have an employee class which has a salary, and he has a name, age, and there is a salary. So when you call a salary with the value, it assigns to the money, and it says how much this guy is earning. So that's what it does. So here when you call salary, it returns value, Karthik earns this much. Okay. So here what we have done is, let's execute this actually. Yeah, so this is just checking the dir, whether if it doesn't start with the underscore, just give back whatever directory has, so directory listing has. So okay, leave that. Let's leave that. Okay. So now for the inheritance, this particular employee is like a general employee for any other employment. For if you take an artist, or if you take a software engineer, or if you take a movie director, a movie actor, everyone is an employee. So that means this could be a reusable construct for us. So that's why. So for example, take this artist, he also has a similar money, he earns this much money, and he has his name and age attribute, but he has an additional uh, method called as art form. So that's basically giving out what job it does, but this is a reusable construct of the employee. So what we can do is, for an artist we remove this and we say this guy inherits some features of employee. So this could be done by just saying artist and specifying employee inside it as an attribute. So this, what it does is basically it inherits all these features, and it will be a part of this artist class. So if you want, now you just call artist and we can check it out. Let's run this. Yeah, so you can check the date of artist. Now this has art form, a salary, because we had a salary over here. Yeah, here, and that is inherited to this. So because this is a subclass of the employee. And when you write, when you initialize something, a salary, you can see in the output Nishant earns this much. This was similar to the what we got with the employee output, although in this artist we don't have the earns, we are calling the salary function. We don't have a salary function, we can call the salary function of the parent. Okay, so yeah, that's all about it. So the final thing is that, yeah, so what we discussed in the functional argument, so you can also pass star args if you don't know what are the arguments you're going to pass for the init, and how much value you're going to pass for that init. So you can, yeah, that's about it. So the final introspection is that so there are three different so we can use has attr, set attr, and get attr. These are the three functions that we are going to use for class operations. So basically what it does is you can check whether a particular class has this attribute. So you define one instance, you create one instance and say this particular instance has this particular attribute, and also you can set the attribute just by passing a string, and it creates an attribute called copy. And you can do again get the attribute of other which is already existing. So if it has, and what we are doing is we are setting this uh, instance ns.copy and assigning the value of data. Basically it's copying the data value and putting it to the newly created attribute called copy. Let's execute this. Yes, so now it has created a ns.copy. Although this did not have a copy attribute, now we created an attribute and now we are able to get that value through ns.copy. So, yeah, these are the some of the operation, and there are pretty much a big list of collection of all the operation that you can perform on class instances. So yeah, this is some basic introduction just to dive into the object oriented programming in Python. Yes.